Starting with the chapter hydrogen. Hydrogen exists as a diatomic molecule as H2. As diatomic, two atoms are here in a molecule of hydrogen. So that is why it is also called dihydrogen. Position of hydrogen in the periodic table. Position of hydrogen in the periodic table. Resemblance with alkali metals. We all know hydrogen is placed in the group 1 in the periodic table with alkali metals because some of the properties of hydrogen they resemble with alkali metals. Now which properties of hydrogen they resemble with alkali metals? First is electronic configuration. Hydrogen has one electron in the K shell. In its last shell, it has one electron. And alkali metals like lithium, its electronic configuration is 2,1. Sodium is also an alkali metal. Electronic configuration 2,8,1. Alkali metals have one electron in their last shell. Similarly, hydrogen also has one electron in its last shell. So in its electronic configuration, hydrogen resembles with alkali metals as both these have one electron in their last shell. Second property, electropositive character. Electropositive character. Hydrogen has a tendency to lose that one electron in its last shell. This is the electron in the first shell of hydrogen. It can lose this electron to form H plus ion, unipositive ion. Similarly, lithium has one electron in its last shell. Sodium has one electron in its last shell. They have a tendency to lose this one electron to attain stable electronic configuration. After losing this one electron which is there in the last shell, they are forming which type of ions? They are forming positive ions. So hydrogen, like alkali metals, are forming electropositive ions. So they are electropositive in nature because they can lose electrons to form electropositive ions. Next property in which hydrogen resembles with alkali metals is oxidation state. Oxidation state. Like HCl, NaCl, KBr, potassium bromide. K is K plus here, bromide is Br minus. In NaCl, Na is Na plus, Cl is minus 1. In HCl, H is plus 1, Cl is minus 1. Oxidation state is the charge, the elements are showing in the compounds when they are combining with other elements, how much is the charge on them. That is called oxidation state. So hydrogen oxidation state is plus 1. Alkali metal Na plus K plus are alkali metals. Their oxidation state is also plus 1. So like alkali metals, hydrogen shows an oxidation state of +1 in its compounds. Next property, combination with electronegative elements. Electronegative elements are non-metals. So we can also write or non-metals. Hydrogen and alkali metals both combine with electronegative elements, that is with non-metals. Like for example, with oxygen, when they combine, they form oxides. Hydrogen combine with oxygen and form hydrogen oxide, that is H2O. Alkali metals like sodium combines with oxygen and forms Na2O, sodium oxide. Potassium also combine with oxygen to form potassium oxide. So with oxygen non-metal, hydrogen and alkali metals, they can both combine to form oxides, halides. Hydrogen can combine with halides. Halide means with halogens, like with Cl, and forms HCl. Alkali metal sodium combines with halogen and forms sodium chloride. Potassium combines with the halogen chlorine and forms potassium chloride. So both hydrogen and alkali metals, they form halides. Sulfides with non-metal, sulfur, when they combine, they form sulfides. Hydrogen combine with sulfur to form hydrogen sulfide. Alkali metal like sodium combines with sulfur to form sodium sulfide. Potassium combines with sulfur to form potassium sulfide, etc. So both hydrogen and alkali metals, they combine with the non-metals. So these are some properties in which hydrogen resembles with alkali metals. Now next we have resemblance with halogens. Hydrogen resembles with alkali metals in some properties, and in some properties it also resembles with halogens, like electronic configuration. Electronic configuration. Hydrogen has one electron in its last shell. It requires one more electron. It requires one more electron to have stable noble gas configuration. Similarly, halogens like Cl has 7 electrons in its last shell. To attain stable configuration, it also requires one more electron. So both they need one electron to have stable configuration. So in electronic configuration, they both resemble with each other. Second property, electronegative character. Electronegative character. Like here, when hydrogen takes one electron, when hydrogen is gaining one electron, it forms H minus. It forms electronegative ion. Hydrogen can lose as well as gain electrons. Similarly, halogens, when they are gaining electron, when halogen Cl is gaining one electron, it forms Cl minus. So both hydrogen and halogens, they can gain electron, and hence they are forming negative ions. They are forming negative ions, that means they are electronegative in nature. Next property in which hydrogen resembles with halogens is ionization enthalpy. Ionization enthalpy of hydrogen is comparable with, it matches with halogens, but much higher than those of alkali metals. What is ionization enthalpy? It is the energy required to lose electrons. It is energy required to lose electrons. So hydrogen ionization enthalpy matches with halogens but is much higher than those of alkali matters. This means hydrogen cannot lose electron easily. Formation of covalent compounds. Both hydrogen and halogens, they have a tendency to form covalent compounds. Like with hydrogen, carbon, silicon, nitrogen. Hydrogen can combine with these to form these compounds. This is methane, silane, this is ammonia. All these compounds are covalent in nature. With halogens, halogens also combine with carbon, with silicon and with the nitrogen and form these compounds which are also covalent in nature. So hydrogen resembles with halogens in its property to form covalent compounds. So from this topic, what we conclude? Our conclusion is, from the above discussion, it follows that hydrogen is unique in its behavior because it is not only resembling with alkali metals and with the halogens in certain properties, but also differ from them in certain other properties. So position of hydrogen is anomalous. Its position is anomalous in the periodic table. Our topic was position of hydrogen in the periodic table. So our conclusion is its position is anomalous in the periodic table. This is our first topic, position of hydrogen in the periodic table. Moving on to the next topic, occurrence of hydrogen. Occurrence of hydrogen. Where we get hydrogen? It is the most abundant element in the universe. Approximately 70% of the total mass of universe is because of hydrogen. Like the giant planets, the big planets such as Saturn, Jupiter are mostly made up of hydrogen, and hydrogen constitutes approximately half of the mass of Sun and stars. And on Earth it is the ninth abundant element. On Earth it is the ninth abundant element. In universe it's the most abundant element, while on the Earth it is the ninth abundant element. And in combined form, not as H2, in combined form like water, it constitutes 15.4% of the Earth's crust and oceans. This is occurrence of hydrogen. Moving on to the next topic, isotopes of hydrogen. Isotopes of hydrogen. What are isotopes of hydrogen, or what are isotopes? Isotopes are atoms of same element. These are atoms of same element which have same atomic number but different mass number. Hydrogen has three isotopes. Hydrogen has three isotopes. These are called protium, deuterium, and tritium. Protium, deuterium, and tritium. These are the three isotopes of hydrogen. Representation of isotopes. How isotopes are represented. For this we use a symbol of an element. Atomic number we write as subscript on the left hand side, and mass number is written as superscript on the left or on the right hand side. This is how we represent isotopes of an element. This can also be written as D, and this is written as T. This is from deuterium and this is from the tritium. Isotope effect. What is the meaning of isotope effect? Since isotopes, they have same atomic number. If atomic number is same, they will have similar chemical properties. But since the masses are different of these, the speed of their reactions will be different. The speed will not be same here. Though they show similar chemical properties, but the speed of these chemical reactions will be different in the isotopes of an element. This type of difference in the properties due to difference in atomic mass is called isotope effect. Next topic. Preparation of dihydrogen. How hydrogen is prepared. First is laboratory method. In lab, how we can prepare it. Laboratory method of preparation of hydrogen. For this, granulated zinc is reacted either with the sulfuric acid or with hydrochloric acid. When granulated zinc is reacted with the sulfuric acid, it forms zinc sulfate with evolution of hydrogen gas. And when it is reacted with HCl, it forms zinc chloride with evolution of hydrogen gas. This is the first method to prepare hydrogen in lab. Second method is zinc can be reacted with aqueous NaOH, with sodium hydroxide, with acid or with the base. When zinc is reacted, it forms a salt with evolution of hydrogen gas. The salt formed here is called sodium zincate. The salt is sodium zincate. These two are the laboratory methods to prepare hydrogen. Now we have commercial methods. Commercially, how we can prepare hydrogen. The first method here is by electrolysis of acidulated water. By electrolysis of which water? Acidulated water. What is acidulated water? Water in which some drops of acid they are added. And why there is a need to add acid here? Because water is a poor conductor of electricity. So just few drops of acid will make it a good conductor, and electrolysis of water can take place. So when electrolysis of water takes place, that is water on electrolysis. Lysis means breaking with the help of electricity. It will break up to form H plus and OH minus ions at cathode. Now when we are doing electrolysis, there will be cathode and anode. Cathode is negatively charged. So positive ions here, they will move towards cathode. H plus ions are moving here towards cathode. They will gain electron here and will change to hydrogen. So hydrogen is forming by doing electrolysis of water. At anode, since anode is positively charged, so negative ions of water, they are moving here and they are changing to water, oxygen and electrons. So they are forming water and oxygen. So electrolysis of water is actually forming hydrogen and oxygen gas. Second commercial method is when we do electrolysis of brine solution. Electrolysis of brine solution when it is done commercially. This is actually done to prepare sodium hydroxide. But along with sodium hydroxide, hydrogen is also formed. So we can say as a byproduct, not a main product, as a byproduct we are getting hydrogen when we do electrolysis of brine solution. Brine solution is NaCl dissolved in water. NaCl in water is known as brine solution. So NaCl on passing electricity will break up to form positive ion Na plus and negative ion Cl minus. Since there is water also, water will also break to form H plus and OH minus ions. At cathode, now since there are two positive ions and two negative ions now, only one positive ion H plus here moves quickly towards cathode and forms hydrogen. It will not let Na plus to go to the cathode. Instead, H plus will move there at cathode and changes to hydrogen. Na plus will remain in the cell. At anode, out of Cl minus and OH minus, Cl minus will discharge at anode. So Cl minus changes to chlorine. At cathode, hydrogen is forming. At anode, chlorine is forming. And in the cell, which ions are left here? Na plus and OH minus ions are left because H plus has moved towards cathode and formed hydrogen. Cl minus has moved towards anode and it has formed the chlorine gas. What is left in the cell is Na plus and OH minus, which combines to form NaOH. So our overall reaction is NaCl plus water. NaCl plus water, which is called a brine solution. This is called a brine solution. On electrolysis, when electrolysis of this solution is done, we will get hydrogen and chlorine, and plus what is left here is NaOH. So this method is actually used to prepare NaOH, caustic soda, but along with that as byproduct, hydrogen is also formed. So this is a second commercial method to prepare hydrogen, that is as a byproduct in electrolysis of brine solution. Our third commercial method, from hydrocarbons. Like if we take methane and react this hydrocarbon with steam, it forms a mixture of carbon monoxide and hydrogen in presence of catalyst nickel and on heating. The mixture of these two gases is called a syngas. Syn is from a word synthesis, or this is called a water gas. So when methane is reacted with steam, when methane is reacted or any hydrocarbon is reacted with steam in presence of catalyst, on heating will get a mixture of carbon monoxide and hydrogen, which is called syngas or water gas. Why this is called a syngas? Because this mixture is used for the synthesis of methanol and a number of hydrocarbons. Since many hydrocarbons or other compounds can be prepared from this mixture, that is why this is also called synthesis gas or syngas. Nowadays, this syngas is prepared from the waste material, like from the sewage, from the sawdust, from the scrap wood, from the newspaper, etc. If the syngas or water gas is prepared from coal by passing steam, CO plus H2, this syngas or water gas is prepared from coal, then this reaction is called coal gasification. This reaction is known as coal gasification reaction if the water gas is prepared from coal. Water gas shift reaction. What is water gas shift reaction? Production of hydrogen can be increased if this CO of syngas is reacted with steam. It is reacted with steam in presence of a catalyst. Then we get CO2 and H2. So hydrogen we can get here from the carbon monoxide that we have in the syngas by passing steam over it.